So guys, we're going to look at reactions of carbonyl compounds, and carbonyl compounds, remember, we have the ketones and the aldehydes. But reaction number one, we're going to see reaction with hydroxyamine. This is hydroxyamine. This is a product called oxime. So we are going to look at we are going to write a possible mechanism. So our ketone is going to be there. Remember, even an aldehyde can undergo the same reaction. So first we shall have protonation, whereby this oxygen here has lone pairs, so it's going to attack the hydrogen, which is an electrophile. So this is going to be a nucleophile, a source of lone pairs, or a source of electrons. So it's going to donate electrons to this hydrogen, which is lacking or which is acting as our electrophile. So we are going to get this H plus H3. So after that, then our hydroxyamine is going to attack it's having lone pairs. Nitrogen has lone pairs. It's going to attack this carbon here, and one bond is going to break. So when this bond breaks, we are going to form C3, or even this, I can put C3 here, then N, H2, or H. But now it means here, at this stage, this nitrogen is having excess bond, so we shall put a positive charge here. And after putting this positive charge, it means we are going to have what we call hydrogen shift, or what we call the proton shift. So during a proton shift, this hydrogen here on nitrogen is going to be given to this oxygen up, and we are going to get C3, or it's going to be O2 plus C3. Then nitrogen is going to remain only with one hydrogen and OH. But now this nitrogen still has lone pairs, so it's going to bring here the lone pairs. They are going to be shared between carbon and nitrogen, and this water is going to break off, so shall have loss of water molecule, so minus water, so we shall end up producing C3, then double bonds N, OH. So reaction between carbonyl compound and hydrazine, we are going to form a product going to be called hydrazone. And in this case, we are starting with propanone. This is propanone, this is hydrazine, and hydrazine is having NH2 and H2, so you can use this nitrogen or this one. So, but we are going to start with protonation, as we saw earlier. C3. So since the oxygen is having lone pairs, so it's going to donate these electrons to the proton, and we are going to get C3. So it means after forming this carbon can be attacked by our nucleophile, and our nucleophile is going to be hydrazine. It's going to be NH2. So all these nitrogen, these two, they are having lone pairs of electrons. So you can use either this or this nitrogen, but not both. So if I decide to use this, it's going to donate electrons to this carbon, and this carbon, since we are having excess bonds, one is going to break off, and shall get C3. See, this is going to become OH, CH3 like that, and this is going to be NH2, and this is going to be having a plus because we are having excess bonds. So what is going to happen next? If you try to remember the previous example, shall have proton shift. So proton shift, it means this hydrogen is going to go up there. It's going to be given to this oxygen, making it a better living group. It's going to form water plus C3, and this is going to be NH2. And what's going to happen next is the lone pairs of electrons are going to donate these bonds, their electrons to carbon and nitrogen to be shared, and this water is going to break off because it has been made a better living group. In here as OH it cannot go, but if you make it water with a positive charge, it means you are making it a better living group. So you shall have minus water, and shall end up having C3, then the double bonds are there, then we shall have our hydrogen there, NH2. So this is having a positive charge because having 4 bonds, this nitrogen is having 4 bonds. So we shall have finally the loss of the proton. To regenerate this proton we used during protonation. So say minus the proton, and shall end up with our product, which is called hydrazone, like that. So it will be the similar mechanism which will take place between any aldehyde, let me say, propanol or ethanol, any aldehyde. It's going to form the same product and it's going to undergo the similar reaction steps. So we are having also other reagents we are calling, for example, we are having other reagents, for example, we are having phenyl hydrazine, which is NH2. Phenyl hydrazine, being on a benzene or being phenyl or being aromatic, it means this nitrogen here, which is attached directly to the benzene ring, it cannot donate electron because the lone pairs on the nitrogen, they will interact with the pi bonds of the benzene to render them to be absent. So it means we are going to use this this nitrogen, we are going to use this nitrogen to cause nucleophilic attack. The lone pairs of electrons on this nitrogen to attack, let me say, you are attacking a species which is having a positive charge there. Let me say you are attacking propanol after protonation. So this is the nitrogen you are going to use. Let me say in this case, your product is going to be having here NH2 in this case. If you use phenyl hydrazine, let me give you a hint. So after using a proton, remember this will be plus, say 3, and you bring your phenyl hydrazine NH2. You are going to use this nitrogen, give out the lone pairs, and this is going to break. So it's going to be the similar thing as it is happening in this case. So you are going to form the product, but you just keep on drawing this and the benzene ring. Then we are also having another one. It's called Bladdy's reagent, or what we call 2,4-dinitrophenyl hydrazine. So this is the formula. This is called also Bladdy's reagent and forms a yellow PPT indicating the presence of the carbonyl compound. So you are going to use the similar nitrogen to cause attack. Let me say in this case, you just keep on drawing the entire thing, and you are going to follow the mechanism in a similar way. And this is the product formed between any carbonyl compound with 2,4-dinitrophenyl hydrazine or hydrazine. Is going to be during practical, it's going to be a yellow precipitate or yellow PPT, and to indicate the presence of the carbonyl compound.